Okay, hello class. So today we want to talk about indices. Indices. Indices is the plural of index. Another word for index is power, or it also means exponent. Exponent. So what does index mean? So if I have a number a raised to x, this is the index or power or exponent, while this is the base. So for example, I have 3 raised to power 2. So this 2 is the index and then 3 is the base. So we have basic rules that guide the operation on indices, index algebra. So we have basic rules that guide in index algebra, rules of indices. And so the first one I will talk about is if I have a number that has a power, a number base with a power, and is multiplying another number, is multiplying the same number with a different index. Same number, you can see the base a, and I have different index. This is same thing as me having it as what? A raised to power x plus y. How did we come about this? Let's look at, for instance, let's take this our a to be a number like 3, and I raise this to power 2 and I multiply it as what? 3 raised to power 3. This is same, what this rule is saying is that this is same thing as what? 3 raised to power 2 plus 3, which is equals to 3 raised to power 5. And if I don't want to use this rule and I solve this directly, my 3 squared is 9, and then 3 raised to power 3 is 27. This is same thing as what? 243. And this is same thing. If I multiply this, 3 times 3 times 3 times 3 times 3 is 1, 2, 3, 4, 5. I have this will give me 9. This is another 9. Then times what? 3. This is 81 times 3, which is 243. So we can, it is safe to say that a raised to power x multiplied by a raised to power y is equals to a raised to power x plus y. So let's call that the first one. The second one we will talk about is what if I have the same base and I'm using it to divide a number with the same base and I'm having different indices. I will have what? This will be the opposite of that. I will have x minus y in this case, meaning that if I have 3 raised to power 3 divided by 3 raised to power 2, the rule is saying I should say 3 raised to power 3 minus 2, which is what? 3 raised to power 1, the same thing as what? 3. If I follow this, this is also 27 divided by 9. This is what? 3. 27 divided by 9 is 3, which is same thing as what we have here. So the rule follows. So we have this rule being the second. And also, what if I have a raised to power x and I am raising that to a power of y? Don't mix it up with this. It's different. This is what? A raised to power x and what? Multiplied, or multiplied by y. The rule says that I should say a raised to power x y. How did we come about this? Let's take an example. If I have 2 raised to power 3, for instance, and then I square it raised to power 2, what the rule says is that I should say 2 raised to power 3 times 2, which is what? 2 raised to power 6. Now, over here, this should have been what? 2 raised to power 8. 2 raised to power 3 is 8. This would give me 8. And then all squared, that's what? 64. And then let's see if 2 raised to power 6 is also what? 64. So that would be 2 times 2 times 2 times 2 times 2 times 2. That is 4, 4, and 4. 4 times 4 is 16, and 16 times 4 is also 64. And so it is safe to say that a raised to power x all multiplied by y is equals to a raised to power xy. Okay, the next one we'll talk about is, what if I have the same powers? I have something like this, a divided by this. Now from the rule, the second rule we talked about, remember this rule we talked about here, this should have given me a raised to power x minus x, which is a raised to power 0. Then what would this give me? A raised to power 0 would be what? Okay, so let's check. If I have a raised to power x divided by a raised to power x, this is just saying this divided by what? This. And so this can easily cancel out and give me 1. Does that mean this is also equal to 1? Let's check with numbers. Let's check it with what? Let's say I have a number. For instance, I have 2 raised to power 3 divided by 2 raised to power 3. This is same thing as me saying 8 divided by 8. Because 2 raised to power 3 is 8 and 2 raised to power 3 is 8. And that's what? 1. That's 1. Wow, that's we already know that the 8 divided by 8 will give me 1. So that means, that follows that if I also do 2 raised to power 3 minus 3, it should give me what? 2 raised to power, to give me 2 raised to power 0. So if this is 1, then this value also, that is why we say that what? Anything raised to power 0 was 1. That's how we come about that. Then we move on. The fifth one we'll talk about is, what if I have a negative index? If I have a negative index, it means I should have it as what? 1 over a raised to power x. So I have what? Negative index. It will give me what? 1 over a raised to power x. What that is saying is that if I have 3 raised to power minus 2, it will be 1 over 3 raised to power 2. Raised to power 2. 1 over 3 raised to power 2. How did we come? Let's cast our mind back to the second rule we also talked about, that division rule. Let's say the power, let's say I have something like 3 raised to power 2 divided by 3 raised to power 3. This would be what? 3 raised to power 2 minus 3, isn't it? And this will give me what? 3 raised to power minus 1. Agreed? Okay. So what this is saying is that if I have this is saying I should have 3 times 3 divided by 3 times 3 times 3. This would cancel this would cancel this. I'm left with 1 here, and I'm left with 3 here. This is what? 1 over 3. So this my 1 over 3 is also giving me, if this from the second rule, which we have already proved, is equal to this, and this from our normal knowledge of what? Division is also this. That means if I have this is also what? Equal to what? This. So I can say this and this are what? Are equal. So that implies that if I have anything raised to power what? A negative, I will have this, like I have